Hello, my friends. I'm Clover. This is Genuinely Approachable Sudoku, and today we are solving Jenga by Philip Newman. This was originally posted on January 16th, 2025, and it is a killer Sudoku. So that means we have standard Sudoku rules, so we're placing the digits 1 through 9 once each in each row, each column, and each outlined 3x3 region. And in addition to that, we have some cages in the grid, and each of these cages is marked with a total. Digits can't repeat in cages. Of course, they can't anyways because the cages all appear solely within a single row, but just in general, that's true in Killer Sudoku. And the digits in that cage have to sum to the clue that is written in the top left corner of the cage. So for instance, these two digits have to sum to 4. Because of that, because they both have to be valid Sudoku digits, they can't be the same. They have to be 1 and 3. That's the only way to make a 4. The 16, similarly, can only ever be 7 and 9. And we're going to go through and we're going to fill in some of the cages that only have one option first. So 5 can either be 1 and 4 or 2 and 3 normally, but here, because there's a 3 in the row, it has to be 1 and 4. 6 can normally be 1 and 5 or 2 and 4, but because there is a 5 here, this must be 2 and 4. 7 normally has 3 options, however, we have ruled out both 1 and 4 from both of the columns covered by the 7 cage, so because we can't use 1 and 6, we can't use 3 and 4, this has to be 2 and 5. And finally, 8 here can't use a 2 or a 1, so it must be 3 plus 5. And we're going to do something very symmetrical to that. 16, 15 with no 7 is a 6 and a 9, and then 14 with no 9 is a 6 and an 8. 13 with no 6 and no 9 has to be 5 and 8, and 12 with no 8 and no 9 must be 5 and 7. Now 7 in 3 cells is always 1, 2, and 4. We have the 2 already, and there's a 1 right there, so this will be our 1, that will be our 4. 20 without a 3 or a 4 has to be either 5, 7, and 8, or 5, 6, and 9. That can't be a 5, and we can't quite finish that yet. 22 always has 2 options in 3 cells. It's either 5, 8, 9 or 6, 7, 9. There's a 6 here, so this will be 5, 8, 9. Exactly. Now this 9 in 3 cells doesn't use a 5, doesn't use a 6. It can't use anything bigger than that because the minimum with like a 7 would be 1 plus 2 plus 7, which is actually 10. So we can only use digits from 1, 2, 3, and 4, which means that we have to do 2, 3, and 4 exactly to make 9. 8 in 3 cells is always either 1, 3, and 4, or 1, 2, and 5, and because there is a 4 in the row, this is going to be 1, 3, and 4. Or sorry, not 1, 3, and 4, 1, 2, and 5. Okay, so that has a 1 and 5 in the column, so that is a 2. We can eliminate 2 here, placing a 2 right there, and then the last remaining cell has to have a 3 or a 4 in it, and we'll work that one out in a minute. The remaining 2 digits here are 7 and 9. We know the order because of that 7. The remaining digits here are 1 and 3, and we know the order because of the 3 right here. 23 is always in 3 cells, 6, 8, and 9, and we know the order there thanks to this 9 here. These 2 cells have to be occupied by a 1 and a 3. The 1-5 pair tells us which way around they go. The 9 we just placed gives us the 8 in this region. And we still need, what? We need 6 and 7 in this region. Those go into the 21 cage. 6 plus 7 is 13. What do we add to that to get 21? We're going to have to add an 8, so that's going to be an 8. This also can't be 8 or 9 in the column any longer. Here we need a 7 and a 9. The 5-9 pair disambiguates that. So now we know there's no 9 in the 20. So that's going to have to be 5, 7, and 8. That's the only option to make a sum of 20 in 3 cells that does not have a 9 anywhere in it. And finally, we're going to do 10. There's no 1 in it, and there's only one way to make a 10 in 3 cells with no 1. It is 2, 3, and 5. And that gives us the entirety of all of our cages, and we can finish up by doing a bit of classic Sudoku. So here we need 2, 6, and 9 to finish this region. And I'm actually not even going to pencil mark that because it looks like that's not quite the right place to start given the other digits that I have here. So what can I put kind of down the middle here? So I need a 1 there and I need a 9 to finish that region. And then here I'm going to need 2, 6, and 7. That can't be 2 or 7. That can't be 7. And that is my 7. Here I need 3, 4, and 8. There's a 3 and 8 there. There's a 3 here, so that's my 8, and that is my 3. Hopefully that's going to make it a little bit easier to fill in the rest of the grid. So here I need 1, 4, and 8. 8's ruled out here, so this is a hidden 8, and then I can do the 1, 4 using the 1 right there. Here I'm going to need a 2, so this is a hidden 2, and I need 6 and 9 to finish the region. So that gives me 8 digits in each of these rows. This one, the last digit is a 3, the last digit here is a 7. Here to finish the row I'm going to need a 4 and an 8, so that's taken care of, and here I need a 6 and a 9. Here I need a 1 and a 4, and here I need a 2 and a 6. And that is how you solve Philip Newman's Jenga. Hope you guys enjoyed that one. To solve it yourself, there is a link in the description below this video, and I will see you again 3 days from now.